So remember what we said? It is an alternative to degrees, but when you're going to be asked to answer a problem, and if they give you the angles in radians, then you need to give the answer in radians. But like I said, you may be more comfortable using degrees because in your mind you see better what a 90-degree angle is, yeah, what a straight line is, what a full circle is. So do you remember all that? Yeah. So you may want to say, okay, I'm going to switch it into degrees, and then at the end, I'll put it back into radians. So how do we do that? So we need to find what is the relation between degree and radian, basically, yeah? So to find that, you've got what we call an arc length and a radius. Do you remember what was the relationship between your circumference, what you call the arc length, and your diameter? What formula did you use to calculate the circumference of a circle? Two pi d. Yeah, so there's something in 2 pi d or 2 pi r. 2 pi r, because 2 pi r would be pi d. So circumference. So anytime you had a circle, yeah, you were told that circumference equal pi d or 2 pi r, because d is just 2 r's, right? Diameter 2 times your radius. Primary school, yeah? Did you do that? Did you think one day you would need it back? No? So we need it back because basically pi is just a ratio. Yeah, pi is just the circumference. Sorry, pi is the circumference divided by the diameter, yeah? C equal pi d. If I make pi the subject, pi is just c over d, yeah? You divide by d both sides. Yeah? Or you can just say as c over 2r, same thing. So if you take any circle, any sizes, you divide the circumference by the diameter, you will get 3 point something. So if you were taught this at primary, if the teacher had come up and brought a lot of wee artifact, wee things that has got a round shape, and ask you, measure the circumference, measure the diameter, and there'll be 20 of you in the class. She'll have 20 different sizes, and every single one of you would have done that. You would have noticed that you'll all end up with that same number. And that's how they found out pi. Yeah, whoever invented pi, the Greek letter that he used, found out that every time he was taking a circle, when he was dividing it by the longest length inside the circle, the diameter, he would get 3.14. And it doesn't matter how big the circle was. So maybe if you had done that manipulation, you would have remembered it a bit better. And you would have come in this class today, and I would have asked you, what is pi? You would have all gone, oh, that is just a ratio. It's the circumference divided by the diameter. But because you learn it like this, you've not used it, what happened in your brain if you don't use something that you've not practiced or manipulated? Eventually, a bit of memory will come back, but you may just forget it, yeah? And some of you might have forgotten. Some of you might say, oh yeah, I remember that. Some of you are just saying, oh, this is so obvious, I'm not going to give the answer. Yeah, so pi is just a ratio. And if I've got a radius here and the arc length, what you get is, so we said arc length C divided by the ratio C divided by R equal 2 pi. Yeah? Because I just time by 2 both sides. But C over R is what we call the full circle. How many degrees is a full circle? 360. So if 360 makes 2 pi, 1 pi will be how much? 180. And that's where it's coming from. Okay. So if you wonder where is that 100, why is pi equal 180? It's because of this. The circumference divided by the diameter is just pi. And a full circle is 360, which is 2 pi. Okay. So circumference, we said 2 pi r. If you divide by r the circumference, you will get 2 pi. So full circle 360 degree is the same as 2 pi radian, or 180 degree is pi radians. Okay, so now you might ask yourself, why did they come up with this? It's to do with 1 radian, basically. What is 1 radian? If you take the radius here, you put it on here, and you measure that angle, that's what they call 1 radian. That's all. That's what 1 radian is to take a circle, take the radius, that's why the radian comes from, RAD comes from the radius, put it onto the circle itself, measure that angle, that is exactly 1 radian. So now we know that 360 is 2 pi radian, or 180 is pi radian. So here, 180 would be 3.14 radian. So you'll have 1, 2, 3, and a bit radian. Yeah, pi radian, basically. So 360 is 2 pi, 180 is pi. Half, half, both sides. What is 90 degree? Yeah, or we just say pi over 2. So if you half that, you need to half that, yeah? So we call it pi over 2. Now, what is 60 degree? Have a look, 60. What did I do to the 180 to get 60? Divide by 3. So then that's why it's pi over 3. So if you divide by 3 that side, you need to do the same on the other side. What is 45 degree? So you take the 90, you half it. That means pi over 2 divide by 2, which become pi over 4. Yeah. So these are the basic ones that you know. And you know that a right angle is pi over 2 now. It's coming back to you. A straight line is pi. A full circle is 2 pi. What is 30 degree? Pi over, yeah, because you half that. If you half pi over 3, it's the same as pi over 6. And then you can find multiples of these. 270. 3 pi over 2, yeah. Time that by 3. 120. Can double that. So 2 pi over 3. 135, 3 pi over 4, 150, 5 times that, 5 pi over 6. So from just that first one, you can see that there's quite a few that we can come up quite easily because they're multiple of degrees. Okay. So that's an easy way for you to be able to call back a few. Is just remember one of them, either the 360 of 180, and look at the number that you're given. If it's a multiple of 180, for example, this is that divided by 6 give me 30, and that means I need to divide that by 6. Okay. Now let's have a look. So for any values to convert degrees into radians, you need to divide by degrees and time by pi. Radians. Yeah. So you divide by 180 and you time by pi. So if I give you 10 degree and I ask you how many radians is that, you do 10 over 180, which is 1 over 18, time pi. So it's pi over 18. So if we divide by 180, then time by pi, to go from radians to degrees is going to be the opposite. You're going to divide by pi and then time by 180. Yeah. So divide by pi and then time by 180. So that's how you convert from one to the other. Remember, you'll allow your calculator to do any of these. So since pi radians is 180, then pi over 180 is 1 degree. Yeah. If 180 makes 100 pound, 1 will be 100 divided by 180. Yeah. Same thing. So 1 degree is pi over 180. So that means if I give you 60 degree, you do 60 times pi divided by 180. If I give you 70 degree and I ask you to put them back into radian, you do 70 times pi divided by 180. Okay. So to convert from degrees to radian, you multiply the degree by pi over 180. Or like we said, divide by 180 times pi, same thing. So let's have a look here. If I ask you to convert 30 degrees to radians, you do 30 times pi over 180. 30 divided by 180, you divide by 10 both top and bottom, yeah? That'd be 3 over 18. 3 over 18, both multiple of 3s. Divide by 3, the top is 1. Divide by 3, 18, you get 6. And because it's pi, it becomes an invisible 1. And that's how quickly you can do 30 in radians. Or if you prefer, use the 180 makes pi and work your way through them. It's up to you. Now to convert 150, you do 150 times pi over 180. And eventually you'll see that you can simplify by dividing by 10 both. Now 5 and 1, 6. Yeah. 8 and 1, 9. That means they both goes into the 3 time table. So that's the tricks that I was telling you earlier on. That means I need to divide both by 3. 15 divided by 3, 5. 18 divided by 3, 6. So please don't leave it 15 pi over 18. Because you might not have noticed that they are in the 3 time table, but I'm sure you can add 2 numbers, yeah? So if you can add 2 digits to help you figure out that they're both multiple of a number, then use that trick. Yeah? So if it's a decimal, same thing, you use your calculator. So if you were to use your calculator and do 76.3 times pi divided by 180, so the pi sign is shift this button here, times 10 to the power of x, you can get pi straight away. That give you a, I think, I don't know how many decimal place for pi. So if you do SD 1, 2, 3, so 9 decimal places it gives you. But again, it's still an approximation, right? Pi's got billions and billions and an infinity number of decimal points after it. So we've not got computers that can give you, but there are quite a few. And then you would type that and you should get 1.33, yeah? Now, how do we convert from radians to degrees? So we said that 1 radian is 180 divided by pi. So you time by 180 and you divide by pi. So you take your calculator and you do that. So if I give you pi over 4 and I ask you to convert them into degree, you just do time 180 divided by pi, which is good because pi and pi cancel each other. And then you do 180 divided by 4. Remember, if you can't remember your 4 timetable, the ones that didn't like math that much, if you can't remember your 4 timetable, I'm sure you can double or half a number, yeah? So half it and half it again. That's how you do the 4 timetable. You time it by 2 and you time it by 2 again. So now you get to the point where you might have not remembered these because you thought, you know what, I'm never going to use it. What's the point of learning the 4 timetable? I'm sure you can remember the 2 timetable because it's an easy way to double or half numbers, yeah? We use that all the time. 2 of you, I give you £15. You're going to know straight away how much each is going to get. You don't need to do a lot of math for that. But that's because you deal with money all the time, yeah? So same thing here, I half it, I get 90 over 2, and then I half it again, I get 45. Pi over 4 is 45 degree. 2 pi over 3, again, we time by 180, we divide by pi. So then that means the pi will simplify. I've got here 1 and 8, that's 9. So I know straight away this is a multiple of 3. 2 times 60, which is 120. Okay. Now, if you given a decimal value, then you use your calculator. And this time you're going to do 0.273 on your calculator time 180 divide by pi. And you give it to 1 decimal place. In this case, make sure when you give to 1 decimal place, you round it correctly, right? That might have been 15.62 or whatever, or 15.59. You round it properly. You don't put 15.9 because you lose the mark, yeah? You're expected at this level to know how to round properly. Okay, if you got any question on that, let me know. And now, for you to do on your own time, I've got all these. Like we said, once we time by 180 divide by 5, get rid of the 5. Well, this one you're going to time by 5, divide by 1. Do that, get all these answers coming from 60 times 5 divided by 180. 65 over 8. And after that, that's 3, that's 9. And I know that 3 over 9 is just above here. answers. You've got the 3 worksheets to practice on. This should be less than 5 minutes. You're allowed a calculator, remember?